Hello, we are Raquel Macías Aybar, María Fernanda Rodríguez García,
Carolina Enrico
from Group 1, and this is our activity number 3, motion of an object, how to calculate its trajectory. In this activity, we are going to explain the different kinds of movements and how to calculate the trajectory of an object according to freefall. The types of movement that we study in these modules were in 1 and 2 dimensions. The movements in one direction can be freefall, vertical throw directed downwards, vertical throw directed upwards, and in 2 dimensions, horizontal throw, parabolic motion, and uniform circular motion. But for this activity, we will focus on freefall and projected motion. Freefall is a motion in one dimension in which gravity is the only force acting upon the object. The initial velocity and the initial position are zero, and they both increase negatively since the object is falling. In this motion, gravity is always negative. There are some equations used to analyze the trajectories, and be the same as the ones from constant acceleration, and we can replace the acceleration value with gravity. Otherwise, projectile motion is the movement of an object thrown or projected into the air that is affected by gravity. The data provided to analyze the trajectory of a projectile is usually its initial velocity and its launch angle, greater than 0 degrees and less than 90 degrees. Since it has a direction, the initial velocity is a vector quantity. It's important to remember that the projectile motion takes place into 2 dimensions, so we can decompose the velocity of its components on each axis. Initial velocity x is equal to initial velocity times cosine, and initial velocity y is equal to initial velocity times sine. And when we have the components, we can obtain the position and velocity of the projectile. The position x is equal to initial velocity x times time, and y is equal to initial velocity y times time plus 1.5 times gravity times time and divided by 2. And velocity x is equal to initial velocity x times time, and velocity y is equal to initial velocity y plus gravity times time.
Using this equation, we can analyze the behavior of the projectile along its trajectory, also known as parabolic motion. In the equation for velocity, you can see that the velocity in the x-axis is constant, but in the y-axis first decreases and then increases negatively until it reaches the ground. This is due to gravity. Now, if we need the velocity of the projectile as a vector, we can obtain it through the components. We can also find the maximum height. The velocity in the x-axis remains constant, but the velocity in the y-axis is zero. When the projectile is at the maximum height, another important concept is the range of flight time. It can be obtained in 2 ways. If we double the time of the maximum height, it must be the time it took to go and then down. The horizontal throw, also known as horizontal projection, is simply a hub of a parabolic motion. An object in a horizontal surface travels horizontally on it, and then when it reaches the end of the surface, it begins to fall vertically, but keeps moving horizontally due to the initial velocity it has. We can also use the equation from parabolic motion, but considering that the initial velocity of the projectile is totally in the x-axis, so the velocity in the y-axis is zero, because there is no angle. Like in free fall, gravity is the only thing that determines the vertical velocity and position. Meanwhile, just like in the parabolic motion, the velocity in the x-axis is the same always because it is constant.
The horizontal position will increase positively, meanwhile the vertical position decreases negatively because our initial position is zero and the projectile is moving downwards. In this case, we can get the maximum height, but we can know the height from which it fell, how long it took for it to fall, and how much it continued moving after falling.
Now, we're going to observe an example of free fall and analyze it.
In In this experiment, we let fall a little bag from a height of 1.75 meters, and we took the time until it reached the ground, which was 0.6 seconds. We already know that in free fall, the initial velocity is 0 meters per second, and gravity is the acceleration that is going to be a value of minus 9.81 meters per second squared. The value we needed to find was the final velocity, and we obtained it with the next equation. Final velocity is equal to initial velocity plus gravity times time. And when substituting these values, we would have that final velocity is equal to 0 plus minus 9.81 times 0.6. And as a result, we would have minus 5.886 meters per second. And to check this result, we also tried with the other equations to make sure it was correct. As we can see, in the equations we get to the same and in some cases very similar results. Free fall can be a very simple motion in one direction, but we found it really interesting how in base of the same equations we can find different data for the solution of problems in physics, and how this becomes into the basics for new topics and to understand how things work in our daily life. This was all for our activity 3. Thank you for your attention.